Rise and shine, babies! Welcome to our next topic. The title is The Function of Baking Ingredients. What is the importance of of functions of baking ingredients? Each of the ingredients we use serve as a particular functions, reacting with each other to produce new combination and create structure, flavor, and texture of the finished baked products.
To be successful in the baking and pastry arts, it is important to have a basic understanding of how baking ingredients function and how they react to each other. Knowledge of these principles and processes will not only help you to follow any formula and produce better quality products, but will also aid in developing formulas of your own creation. The basic ingredients used in baking typically fulfill more than one function in the finished product. Eggs, for example, can act as a stabilizer, leavener, and/or thickener. Understanding how ingredients function will give a chef the ability to create balanced baking formulas and to understand what went wrong when something doesn't work. Stabilizers, gelatin, liquefier, pectin, leaveners, biological, chemical, mechanical. Stabilizers. A stabilizer is any ingredient that helps to develop the solid structure or framework of a finished product. It does this in one of two ways, either by toughening or tightening a dough, or by thickening a mixture. Flour and eggs are examples of ingredients that lend structure and nutritional value to a finished product. Flour acts as a binding and absorbing agent. It is the gluten, the protein component in flour, that builds structure and strength in baked goods, whereas the starch present in the flour makes a useful thickener. Eggs lend additional stability during baking. They influence the texture and grain as well, and by facilitating the incorporation and distribution of air, they promote an even grained and fine texture. Eggs act to thicken through the coalition of proteins. Eggs also have leavening power, as eggs, whole yolks or whites, are whipped. They trap air that expands when heated, resulting in a larger and lighter product. Gelatin. Gelatin is used to produce light, delicate foams that are firmly set, such as Bavarian cream, mousse, and stabilized whipped cream. Such foams retain the shape of a mold even after unmolding and can be sliced. Available in both powder and sheets. Gelatin must first be softened or bloomed in a cool liquid. Once the gelatin has absorbed the liquid, it is gently heated to melt the crystals, either by adding the softened gelatin or a hot mixture, such as a hot custard sauce, or by gently heating the gelatin over simmering water. Pectin. Pectin is a carbohydrate derived from the cell walls of certain fruits. Some common sources of pectin are apples, cranberries, and currants. Liquefiers. Liquefiers help to loosen or tenderize a dough or butter. Water, milk, and other liquids, fats, and sugar act as liquefiers. Water acts to dilute or liquefy water-soluble ingredients such as sugar and salt. It also facilitates the even distribution of sugar, salt, and yeast. In a dough, if these ingredients are mixed thoroughly with the water before introducing the remaining ingredients in the formula. Water also acts to leaven, as it changes to steam and expands. Milk performs many of the same functions as water, but because of its additional components, fat, sugar, minerals, and protein, it serves a number of other functions and adds flavor as well. As the sugar, lactose in milk caramelizes, it gives a rich color to the product surface, and it can also aid in development of a firm crust. The lactic acid in milk has a tightening effect on the proteins in flour, which serves to increase stability, resulting in a product with a fine grain and texture. Leaveners, biological, chemical, mechanical. To leaven is to raise or to make lighter. There are several ways to accomplish this in baking: with yeast, also known as biological leaveners, with chemical agents such as baking powder or baking soda, and through steam, also known as mechanical leavening. Each method is best suited to specific applications and all produce very different results. Different leavening methods may be used alone or in conjunction with one another to yield particular effects. Biological leaveners. Organic leaveners are based on yeast, a living organism that feeds on sugars and produces alcohol and carbon dioxide, the gas that lightens a dough to give it the proper texture. Unlike chemical leaveners, organic leaveners take a substantial amount of time to do their job. The yeast has to grow and reproduce sufficiently to fill the dough with air pockets. For this to take place, the temperature must be controlled carefully. Fresh or compressed, yeast must be kept refrigerated to maintain its viability. Active dry yeast and instant yeast are two types of granular yeast. These should be kept refrigerated after opening and must be kept dry until use. Active dry or instant yeast in an unopened package is in a completely dormant stage and may be stored at room temperature and opened for up to 1 year. Chemical leaveners. With baking soda and baking powder, an alkaline ingredient, usually sodium bicarbonate, interacts with an acid already present in baking powder or in an ingredient such as buttermilk, sour cream, yogurt, or chocolate to leaven the product. Baking powder is a combination of an alkali, an acid, and a starch. The alkali and acid produce carbon dioxide when combined in the presence of liquid. When heated during baking, the carbon dioxide expands and gives the baked good its characteristic texture, known as crumb. This process of expansion happens rapidly. Hence, many items prepared with chemical leaveners are called quick breads. Double-acting baking powder is so called because a first action occurs in the presence of moisture in the butter and a second action is initiated by the presence of heat. That is, the baking powder reacts once when it is mixed with the butter's liquids and again when the butter is placed in a hot oven. Mechanical leaveners. Steam, which is produced when liquids in a butter or dough are heated. In a mechanical leavener that is sometimes referred to as a physical leavener, steam is the living agent in sponge cakes and souffles. It also plays a vital role in puff, pastry, croissants, and Danish pastry, where the steam is trapped between layers of dough, causing them to separate and raise. When air is incorporated into a butter through either whipping or creaming an ingredient before it is incorporated into the final butter, heat causes the air pockets into the butter or dough to expand.